dividing radicals. First things, there are lots of different ways to do this, lots of different ways to look at it when you're dividing. Okay, and what I mean by that, if you have the square root of a over b, you can look at that as the square root of a over the square root of b. And likewise, if you're given the square root of a over the square root of b, you can combine that to be the square root of a over b. Okay, so first thing you want to do, always see if you have perfect squares. If there are, simplify them. Okay, second thing, see if you can divide the bottom into the top or vice versa. Or just simplify. See if you can simplify the fraction. Okay. Number 3, simplify your radicals. That's doing what we did in class 1. And 4, rationalize the denominator. That's a new term. We'll go over what that means. Basically, you cannot leave radicals in the denominator. That's not okay. Alright, you just can't. It follows mathematical rules. You cannot leave radicals in the denominator. So I'll show you how to get rid of those. Now, this first one, do we have perfect squares? Yeah. Do we need to list the perfect squares? Let's list them just for fun. 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10. We'll stop there. Okay, so square root of 9, we know that is 3. Square root of 16, that is 4. Bingo, we're done. We like those problems. Next one, square root of 25, that's on our list. Square root of 36 is on our list. 5, 6. Oh, I love problems like that. All right, the next one. Let's combine that. Okay, we know neither of them are perfect squares, so I'm going to rewrite that to the square root of 27 divided by 3. Can we divide there? Yeah, 27 divided by 3 is 9. So that's the square root of 9, and what is the square root of 9? You got it. It is 3. Next one. Neither of those are perfect square, so let's combine them. 48 divided by 12. That is 4, and the square root of 4 is 2. Okay, and there you go with simplifying. Okay, with the quotients. That means when you divide it, just in case you forgot what quotient meant. Alright, so let's do some more examples. We lost our perfect squares, so let's run them again. 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10. Alright, so this next one, 42 and 6, neither are perfect squares, so let's combine it to 1. 42 divided by 6 is 7, and the square root of 7, not a perfect square, no perfect squares go into it, so that is it. Okay. The next one, let's look about just what's inside first, but don't forget that 2 for the end. Keep that in mind. 5 and 20, can we reduce that? Yeah, you're right. 5 goes into 5 once, 5 goes into 24 times. So now that we have the square root of 1/4, it might be easier to look at it as the square root of 1 divided by the square root of 4. Don't forget that 2, brought that down. So the square root of 1 is 1, so we have 2 times 1, and the square root of 4 is 2. So that is 2 over 2, which is 1. Alright, next. 6 and 27. Neither are perfect squares, but we can reduce it. 3 goes into both of them. 3 goes into 6 twice. 3 goes into 27 9 times. From there, you can split it up. Root 2 over root 9. And what is the square root of 9? 3. So you have 1 times root 2 to give you root 2 on top, and then 5 times 3 on the bottom is 15. And that's your answer. Next, 65 and 16. Let's see, does anything go into both of those? I don't think so. No, I don't think so. So we have 1 times root 65. 2, root 16. What is the square root of 16? 4. So we have the square root of 65 over 2 times 4, which is 8. 65 is a big number, but if you look at that, that'd be right here. None of these go into 65 evenly. Okay, so that is it. Square root of 65 over 8. Okay, that is more examples on just simplifying. We have not had a radical left in the denominator yet, so let's go to the next slide and look at what happens when we are left with a radical in the denominator. We have to do what's called rationalizing, which involves multiplying the numerator and denominator by a factor that eliminates radicals in the denominator. Now, if you remember from the last class, in the last class we talked about the fact if we have the square root of 5 times the square root of 5, that equals 5. Right? Hopefully you remember that. So, what this means is when we multiply the numerator and denominator by a factor that eliminates radicals, we can eliminate radical by multiplying it by itself. So here, say we multiply by root 5. Now we can't just multiply the denominator by that because that is changing the problem. So we have to multiply both numerator and denominator by that. So then you have 1 times root 5 on the top. You guys know root 5 over root 5 is 1, right? Anytime you have something over itself, and 1 over root 5 times 1 is just 1 over root 5. It doesn't change the problem. So it's like when we solve equations, what you do to one side you have to do to the other. Well, here what you do to the top you have to do to the bottom, okay, in order to keep that multiplying by 1. So back to the problem, 1 times root 5 is root 5, and then root 5 times root 5 is 5. That is it. You cannot simplify because 5 is on the inside on the top, 5 is on the outside on the bottom, and you can't simplify outside to inside. Okay. Next problem, root 7 over root 3. Nothing can be simplified there. Okay, so I need to multiply. Okay, so when you multiply here, what you're going to multiply by is root 3. 7 and 3 cannot be reduced at all, so we're going to multiply by root 3. Root 7 times root 3 on the top. You can do that, so that's going to be root 21 on the top. On the bottom, root 3 times root 3 is 3. So root 21 over 3. And that's it. Again, you cannot simplify. I know it's tempting to say, oh, 3 goes into 21 7 times, but no, that cannot be simplified. 21 is on the inside, 3 is not. So you cannot simplify there. That is your final answer. Okay. Next one, if we look at this, 6 and 3, that can be reduced. Okay, so what we want to do is I'm going to look at this as 3/6 times square root of 6/3. Well, 3/6 reduces down to 1/2, and then 6/3 is 2. So 1 times root 2 is root 2, so you'll just have root 2 over 2. Again, do not simplify that, okay? Root 2 is on the inside, 2 is on the outside. So that's it there. The last slide, I believe you are trying these on your own, okay? Again, make sure you look, if they're perfect squares, simplify, okay? If you can simplify the fraction, okay, divide the top into the bottom or vice versa, you want to simplify fraction. Next, okay, look for simplifying the radicals, okay? Sometimes you're going to have to do that and then you can simplify more. Rationalize the denominator. Don't forget to do that. Do not leave a radical in the denominator. Okay, here are your you try problems. Try all of them, please. We will go over them in the next class.